And get in here. So obviously this chapter is a pretty hefty one in terms of information. I really tried to focus on the main concepts, topics that we have utilized pretty much throughout majority of this chapter. Okay. Okay, we go. Let's start because we have slightly more than the typical length in terms of questions here. The first question is, what is the formula that depicts the relationship between frequency, wavelength, and speed of light? This is something that we learned way back in the beginning. That is C equals nu times wavelength, or frequency, nu times lambda, frequency times wavelength, okay? Anybody tell me what the value for speed of light is? Don't want to forget that one. 3.00 times 10 to the 8th meters per second. Okay, so that's a very important number to know. Second question, which electronic transition results in highest energy photon? N equals 5 to N equals 2, or N equals 5 to N equals 1. Think about that for a moment, how you would respond to that. And what we should have is N equals 5 to N equals 1, because there is a larger difference that the electron is moving. So the greater the difference, the greater the amount of energy that photon is. Question 3, what did Bohr say about electron energies? Bohr stated that energies are quantized, meaning they come in little packets. That's an important thing to know as well. Obviously, it's on here. Next, which object will have the shortest wavelength? This goes back to de Broglie, and he talked about how basically if light can behave like matter, then matter should have some wave-like properties. Okay, so we've got a basketball, baseball, golf ball, the moon, and a ping pong ball. Which will have the shortest wavelength? Or according to de Broglie, the moon will. It's all based off of the denominator here. The momentum of an object, where the momentum of the object takes into consideration the mass multiplied by the velocity of an object. So, the larger the mass, the smaller the wavelength is going to be. That's why, of those choices, the moon will have the shortest wavelength. Question 5. Place in order of smallest to largest wavelength. Again, if you need to, go back and listen to the electromagnetic spectrum song. Okay? Think about the chorus portion of that song. So you have red visible light, infrared, orange visible light, and ultraviolet. Okay, so we have a couple from the visible light spectrum. We have 2 that are outside of that visible light spectrum. Okay, so again, it's in order of smallest to largest wavelength. So if you envision the electromagnetic spectrum, as you go left to right, your wavelength will increase. So, ultraviolet light, it is furthest to the left of the visible light spectrum. In fact, it is just to the left of the visible light spectrum. Then as we continue going right, we're going to encounter orange visible light next, followed by red visible light, and then infrared. Infrared is just before red visible light on the spectrum. So again, this is going left to right on the spectrum. Question 6. A spectrum containing radiation of only specific wavelengths is called what? And this goes back to when we became pirates for a little bit, using those spectroscopes, okay? Think about what you saw in those spectroscopes. You saw very thin lines of color with large gaps in between them, okay? And so that's what this question is pertaining to. Radiation, which is just light, that contains only specific wavelengths. That is what we looked at. We looked at line spectrums. Okay, so that's the definition of a line spectrum. Question 7. Yes, I changed format. Which of the subshells below do not exist due to the constraints upon the angular momentum quantum number? We have 2D, 2P, 2S, all of the above, or none of the above. Well, you got to start thinking about this. Okay, what numbers do these letters represent? Well, D represents 2, P represents 1, and S represents 0. And you have to think about the allowable values for your quantum numbers. These subshell letters are in the angular momentum quantum number, L. Okay? L can only have values equal to 0 all the way to n minus 1. So then you recall that and go back and say, well, you know, S is 0. Well, that's within the range. P is equal to 1, which, you know, for L, it could be 0 and 1. So that's still good. D is the one in question because D represents L number or L value of 2. So if you have a principal quantum number of 2 and an L value of 2, that can't happen. That cannot exist because L must be 0 to n minus 1. Since D is equal or represents 2, that will not exist. 2D will not exist as a quantum number. Question 8. In a P sub Y orbital, what does the Y denote? This is where I was really trying to emphasize when we were looking at the P orbitals, when we actually saw the shapes and the orientation in space. We saw that the P orbital has actually 3 orbitals in space. And so that Y, really all it does is it denotes the axis which the orbital is aligned. The axis that P are can be found on are X, Y, and Z. Question 9. How many electrons, should be electrons, how many electrons can the F subshell hold at maximum? So think about what I've had you write down during all the times we talked about quantum numbers, as well as when we talked about electron configuration. How many maximum electrons can the F subshell hold? And that is 14. D subshell is 10. P subshell is 6. S subshell is 2. Question 10. If an electron has a principal quantum number of, or n, of 2, and an angular momentum quantum number, L, of 1, what would this subshell designation be? Well, first thing is when you do this, you always want to put your principal quantum number first, so 2. And if L is equal to 1, what letter does 1 represent? That will be P. So your designation would be 2P. Question 11. The lowest orbital energy is reached when the number of electrons with the same spin is maximized. Is the statement of what? I'm going to ask you this question. If the lowest orbital energy is reached when the number of electrons with the same spin is maximized, in the statement of what? Let me know what that is. We just talked about it Friday. Hund's rule. Okay, that's Hund's rule. He's the reason why when we have orbital subshells like P, D, and F, where we have to go make sure everybody has an up arrow before you can go back and have seconds on that subshell. Because that is maximizing the number of electrons with the same spin. Question 12. What element has a valence electron configuration of 3s1? I want you to take a look at your periodic table. Hopefully you have it out. 3s1. Anybody having sodium? Very good. Very good. Okay, I said valence electron configuration of 3s1. Okay, again, those valence electrons are those found in the outermost energy level. Question 13. What orbital is representative of the transition metal? Metals. Anybody know what orbital that is? D orbital. Question 14. And this involves a little bit of math, but you don't have to do it. You don't have to do it right now. Okay, I'm going to walk you through it. What is the wavelength for a frequency of 5.50 times 10 to the 14th s to the minus 1? So, in order to solve this, you're going to take that equation we saw in our very first question, C equals frequency times wavelength. You're going to rearrange it to solve for wavelength, and you do that by taking the speed of light divided by the frequency. Okay? And so just simply you plug it into your calculator, and you'll get this number. Either of these answers is correct. 5.45 times 10 to the negative 7th meters, or 545 nanometers. Okay? If you feel comfortable enough to put it into metric values, by all means, but either one of these formats would be acceptable. Question 15, write the condensed electron configuration for element S, which is sulfur. It is element number 16 on the periodic table. Again, we're talking about condensed. Can tell me what noble gas we're going to use for the condensed version, for this condensed version? Neon, exactly. And very important, and I stressed this when we were doing this. The noble gases must be placed in brackets for it to be considered correct. Okay? So you start at neon. That's the end of the row. You go down back to the start. 3s2, 3p4. Question 16. I'm going to ask you this question. What element corresponds to the following electron configuration? Kr, or krypton, 5s2, 4d10, 5p1. Indium. Very good. Very good. Oops. That was pretty quickly, actually. All right. So for tomorrow, so actually, I'm going to go ahead and cancel my record. Stop my recording here real quick.